Okay, so on our chapter review, just to review, when you're asked to graph the function and its parent function and describe the transformation. I'm going to start out with number 2. I'm not going to do all of them. We'll look at number 2. The first thing you have to know is what the parent function is. You look at number 2. What is the parent function? It's absolute value. Or that's the family, right? Absolute value is the family. Absolute value. But the parent function would be f of x equals absolute value of x. That's the parent function. You have to know the parent function points. If you can't look at the graph and just graph it, then you can make a table. And this is what yesterday some of you were doing, which is totally fine. I don't need to make the table because I've done it so many times. You haven't done it so many times. So maybe you need this table of parent function points where you pick x's and plug them into absolute value of x's. Maybe the x's I want to choose are -2, -1, 0, 1, 2. Maybe I want more than that, 3. It's kind of up to you. And when you do absolute value, what does absolute value do? It makes it positive. So I will have 2, 1, 0, 1, 2, 3. This is our parent function. I'm going to dash these on the graph. Like a V. I put away the straight edges yesterday, but they are in the room. If you don't mind using your own straight edge, your student ID works really well. You can grab one. Your student ID from last year works really well. Driver's license, credit card, library card, side of your planner, or you can borrow one. I think the only people that got them were people who did like pictures over the summer. I think sophomores did that. Yeah.
Yeah, I did that, but I didn't get my ID.
Oh, I don't know why. So this is the parent function. Now we have to do transformations, and transformations come from what is different from the parent function to the g function. What's different? There's a 2 in front of it. What operation is that one? What kind of stretch? You are right. Now before jumping right in and just writing all that, I just want to remind you it was 5th or 6th. So it might have just been 6th spell. But just a reminder, if we have, now some of the stuff's on the board already. You've got the outside and the inside, vertical, horizontal, like all that stuff has been there for 2 weeks. I haven't erased it yet. So it was there for your last quiz. Okay. Eventually it'll get erased, but probably not this week. But what will not be there, what you do need to know is the 3 different kinds of transformations you have. Not talking vertical or horizontal, just the kinds of transformations. If you have like a stretch or a shrink, any kind of stretch or shrink, that's going to be a number that is doing what in the equation? What's this 2 doing to the absolute value of x? What operation? No, what is the 2 doing to the x? It is multiplying. It is multiplying. Operations are things like add, subtract, multiply, divide. This is a number that is multiplied. So if you have a number that is multiplied, it will be a stretch or a shrink. If you have a translation, remember translations are where we go up, down, left, or right. If we have translation, what is that number doing to the equation? Number is adding or subtracting. That's going to determine that it is a translation. And then our third kind of transformations is a reflection. And what in the equation tells us we have a reflection? It's really multiplying by a negative 1. So it looks like a negative, right? Because we don't normally write the 1 with it. It's just negative something. So those are your 3 kinds of transformations. And then from there, you have to also determine if it's vertical or horizontal. If anything horizontal pops up, if anything is horizontal, what do we have to remember special about horizontal? It's inside,
The opposite operation.
and it is the opposite operation. Like, that's the biggest thing, is it's opposite of what you would see there. Okay. So I just wrote that on the back of my page. I'm recording this, so if you need to go back and get it later, it's going to be posted. So going back to question 2, going back to what Max just yelled out before, he said this is a vertical stretch. Why will I agree with him that it is vertical? Why? It's on the outside of the absolute value. And why is it a stretch? It's bigger than 1. So anything vertical affects that value, the x or the y value. Anything vertical is that the input or the output? The output. So if you're using a table, we would now take our y values and multiply them all by 2. Just the exact same way it says to do it right here. Take absolute value of x, multiply by 2. 4, 2, 0, 2, 4, 6. And when we graph, we ignore the old x's in the, or the old order. 1, 2, 0, 0. I think my pencil's about to break. Break here. Yeah, and it broke. There we go. Now I have my original. Oh, I forgot to write down vertical stretch. Though. Let me do that real fast, but my pencil broke. So I forgot to write down my transformation. This is a, I don't know where, I didn't leave space for it either. Vertical stretch factor of, when we say factor of, you're asking what do you multiply by? 2. Yes. What? Yes. Same stuff, shorter version. You hold on to it, and you're supposed to check it already. You haven't checked it. Okay. So you need to check it because we have a test next class, and all of that combined is you studying for the test. How do you study for math? You do the problems over and over again until they're right every single time. So that's why you have so many problems and answer keys. So you can make sure that you are doing them right. That's how you study for math. I'm trying to help you learn how to study for math. Okay. One more. Let's do 4. And again, if you know what you're doing, you can work ahead. If you need this extra review, totally fine. So I'm going to first determine what kind of function the parent function is. So it's quadratic, that's the family name. But I need the actual function, which is f of x equals x squared. After I have the function, now I need points for that function. So I'm going to put numbers in for x that I can square. Then I'm going to square them. And remember, when you take a -3 and you multiply it by itself, it becomes a positive 9. Then I'm going to plot those And I'm doing it fast because I have done this so many times that I can do it fast. I'm going to plot those and dash the parent function. Next, we look for transformations. How is x squared and x minus 3 squared different? Max.
Goes to the right 3.
Okay, so you are totally right. But let me ask it in shorter questions. Is it horizontal or vertical? Everybody. Why? It's inside the squared. Is it a stretch or shrink? Is it a translation? Or is it a reflection? Why, Bryce? Why is it a translation? Because we're adding or subtracting. And you are right, it does move to the right. But why does it move to the right and not the left? This is a negative number. Because anything horizontal is opposite. So we will write down, translate 3 units to the right. And then you could literally take this entire thing and move it 3 units to the right, every point. You can do it that way. Or use a table. Either is fine. If you need to see the table, am I going to put the number on the x side or the y side? What is moving to the right? Is that x's or y's? Horizontal, is that x's or y's? Right is horizontal. So we will, on the horizontal side, add 3. So the words and the table are the same. The equation's the thing that's opposite. The words and the table are the same. I'm adding 3 and I get 0, 1, 2, 3, 4, 5, 6. And then you graph your new x's and your original y's. And it should look like your graph. Again, I did not need a table for that, but if it helps you to use a table, then use a table. We're going to be using tables a lot coming up when we get to harder stuff. And then the last thing that a lot of people were asking questions about yesterday that I'd like to review is writing. Writing the equations. Writing the equations. I'll look at which ones are here real fast. There's actually not that many hard ones on here. Looking at the first equation, translation 3 units left. You decide, is that horizontal or is that vertical? To the left is which direction?
Right. Plus.
Is it horizontal or vertical?
Horizontal.
That's horizontal. So we know that we have to do something where it's f of, and it goes on the inside. The x has to be there. And then Avneet yelled out,
This is what I did.
if it's left, what do we do?
This is what I did. Since it's inside, right?
Yeah.
I just added 3 to the 2 inside.
You will. You will.
So it would be easier. So
You will.
eliminate less steps.
You will, and I'm going to get there too. But when it gets more complicated, we need to understand that what we are doing is we are taking out x, and we are using the substitution method and replacing x with x plus 3, right? Which is what you told me to do, Devin. You just didn't want to do that part.
Yeah, no, I didn't quite know that. That's where it messes me up.
Mm-hmm.
So that's
Because that's the stuff that's new to you.
It's old.
No. So I'm going to replace x with parenthesis x plus 3. Then I still have that plus 2. And then I have that subtraction 5 out there. From there, you can add together the 3 and the 2. So we have x plus 5, and then subtract 5. You can't do anything else to that one. That would be the answer. The one that was more difficult was the were in the assignment yesterday.
Yeah, they were really hard.
Is it number 6 was the first one of those? I'll just go over that first one. I'm pretty sure.
One.
I don't have it in front of me right now.
I think so. I don't know. I think so. Oh, wait. Yeah, it's 6.
2x plus 4 and then 7 to the left. Okay, this one I answered so many questions on yesterday, and not everybody had tried it, so you might still have a question on it. So this one has to translate 7 to the left, so we recognize that as being horizontal. That means it's going to be inside. That means it's going to be opposite operation. So for my g of x, I'm going to do f of, and what am I going to put inside? I'm going to put x plus 7. But this one was more challenging because there was a 2 in front of the x. That's what made this one more challenging than the one we just did together. Because I still have to replace the x, but I'm only replacing x. So I still have the 2 there, and I still have the plus 4 outside of that parenthesis, and I put in x plus 7. So I'm taking out the x, and I'm putting in that transformation x plus 7. But now I have to simplify it. What do I do to simplify? Distribute property, and then combine like terms. And we should have 2x plus 18. So that one I went around and helped a lot of people with too. So I'm going to give you the rest of the time to work. I'm going to walk around and answer as many questions as I possibly can, but there's only one of me. So try to use each other as well. And then I am here after school. I am here after school tomorrow. I am here during XH tomorrow. Oh, after school tomorrow does not help you though.
Yeah, it does.
I'm here before school tomorrow, and I'm here XH tomorrow, and I'm here after school today, and I'm here during this bell right now. You could also reach me at home if you have a question. You could send me a message, a DM on Instagram, and then it'll pop right on my phone, and then I can.
FaceTime you.
No, I don't have iPhone. And I.
FaceTime on Instagram.
Oh, and I don't want to.
You can
I don't like seeing my face on the computer.
grab a whiteboard and do like, so this is how you do the problem. Okay?
Oh, I'm pretty good at explaining,
So, we do this one.
texting it out too. What is your question?
We always look at distributed properties. It is weird.
As opposed to what? I don't know how you'd shorten it without distributing.
When I do it, I don't use it.
Do you use it and not really think that you're using it? Did you get the same answer? So if you got the same answer, then you're using the distributive product.
So we always gonna do it.
I have a question.
If it's that kind,